Solving problems involving multiple angle identities can be somewhat challenging. It's real important to keep your identity or your formula sheet in front of you so you can see some of these identities to work with. First of all, if you're supposed to find the double angle for the sine, cosine, and tangent, you're going to mainly focus on the double angle identities. Now, when they give you the tangent of theta equals 4/3 and it's in the interval from pi to pi, 3 pi over 2, you're talking about the third quadrant because this is pi and this is 3 pi over 2. So I want to go ahead and draw this. So I'm just going to draw an angle in that third quadrant and know that the tangent of that theta is going to be 4/3, which means you have a 3, 4, 5 triangle. And so I want to write down that the sine of theta equals, and again, Santa Claus, SATC, means that the tangent is positive, sine and cosine are negative 4/5, and the cosine of theta is equal to a negative 3/5. Now, real important to get the positive and negatives correctly here. One missed symbol, one missed positive or negative is going to yield the wrong answer. So to start with, sine 2 theta equals 2 sine theta cosine theta, and then it's just a matter of substituting in. 2 times negative 4/5 times the cosine of 3/5, which is, let's see, 1224 over 25. And if you look at the cosine 2 theta, now you can use any one of these three, and they will give you all the same answer as long as you do them correctly. So I'll just do 1 minus 2 times sine squared theta. And so it looks like this. Therefore, it's going to be, let's see, 16 times 2 is 32/25. And you're going to have 25 minus 32 is a negative 7/25. 25 fifths minus 32 fifths, negative 7/25. So that's going to give you sine and cosine. Now to find the tangent of 2 theta, you could use this identity right here, or you could just go ahead and put sine over the cosine, and that's going to be the easiest to do right there. So that becomes this, multiply top and bottom by 25 and get 24 over negative 7. So a negative 24/7 will give you the answer for the tangent of 2 theta. Going down to another problem, let's say you have the sine of 22.5. Now, sine of 22.5 is going to give you the option of doing 45 divided by 2, which you have right here. Sine 45 divided by 2. So let's go ahead and rewrite this. This is going to equal the sine of 45 divided by 2, which equals, and again, looking at this formula, it's going to give you this right here. Now, real important, before I go any further, I want to talk a little bit about which sign to use. And this is a way that you can remember what sign to use. If theta is in the fourth quadrant, then if you have it, it's going to go to this quadrant, which is going to be the second quadrant. If theta's in the third quadrant, then when you have it, it's going to go in the second. Similarly, if theta is in the second quadrant, you have it, you're going to go in the first, and the same thing as the first. Now, let's say, for example, theta is between 180 and 270. and you have it, it becomes 90 theta over 2 and 135. So it's now in the third, we have it, it's going to move to the second, which would be right here, second quadrant. Now that's important because now you know the half angle and which quadrant it's going to be in. This is 45, we know what angle that is, so it's going to be positive. But looking at the equation that I want to use, it's this one right here, which means that it's going to be plus or minus 1 minus cosine 45 divided by 2. And I want to do a positive because I know this is going to be positive and not negative. So this answer is going to be 1 minus square root of 2 over 2 all over 2. And you could make that a little bit easier by multiplying by 2 over 2. A little bit simpler form, 2 minus square root of 2 when you distribute that 2 through, all over 4. Basically, you would do the same idea here, but this right here, 11/12, you could rewrite that as 2 times 11 pi over 6. 11 pi over 6 times 1/2. Sorry, so it's not 2, it's 1/2. Going to make a couple changes here. And so now I'm going to rewrite this as the cosine of 1/2 times 11 pi over 6. So in this case, it's like this, where you're going to actually focus on your theta, which is this. And if I were to rewrite this, it would be equal to plus or minus 1 plus cosine of 11 pi over 6 all divided by 2. And you would know that this, for example, is in the second quadrant. So you know that the cosine is going to be negative. So you know it's going to be a negative 1. Let's see, cosine 11 pi over 6, that's the fourth quadrant. And so that's going to be positive square root of 3 over 2, all divided by 2, and then you would simplify that. I'm just going to be going through one last example going forward. Now, when I look at this last one, it's solving the equation on the interval. And so I want to set both of those equal to 0. Cosine theta equals 0, and the sine 2 theta is equal to 0. Now, I'm going to remember that the cosine theta equals 0 at these 2 points. So theta can equal pi over 2 or 3 pi over 2. Part of my answer. Sine 2 theta equals 0. Now, when does that occur? Well, if I were to think about this equaling 0, then I know that that is going to equal 0 at these points. So I know now that 2 theta can equal 0 at 0, or at pi, or at 2 pi, or at 3 pi. And so if I divide both sides by 2 as these options, my theta can equal 0, or pi over 2, or pi, 3 pi over 2. And if it continued 4 pi over 2, but I can't include 2 pi as my answer. So overall, my answer is going to be theta equals 0, pi over 2, pi, and 3 pi over 2. So solving equations, you can solve for a multiple angle by setting the multiple angle equal to the options and then solving for the cases. Now, one other part that you could do is a little bit cleaner method would be you could say 2 theta is equal to, and then see the pattern that it's going to be pi k, where k is a particular integer. So theta equals pi over 2k, and now you can substitute in for 0, 1, 2, 3, and get these particular answers over here. So a couple ways of thinking about how to get those answers. Keep those identities nice and handy, and solving the problems will be a little bit easier.